Hi guys, I hope everyone is doing well. So let's dive into the technicality of the work. So we have an investigation here. I don't think I'm gonna go through that. I'll skip that. And I'll really dive into a discriminant and talk about that, the technicality part of things. So we have this guy here. We call it a discriminant. It's called delta. It's a delta. It's basically a discriminant. So if you look at, this is the quadratic equation, that's really where the discriminant is. That's the business that's going to tell us about the nature of roots. So if that business becomes negative or anything, you can say a lot more about the nature of roots depending on what's happening under that square root, and which is actually the discriminant, right? So let's look at a few cases of what's really happening. If we already know what nature of roots mean, we already sort of like understand what's happening. So all those cases that we've seen before, we're now going to look at how do we know those cases just from an equation, right? You understand? So when you see the graphs, you can tell, that one is imaginary. You can tell, that one has two roots, that one has unequal roots, and stuff like that. So this one is imaginary roots and all that. So now, if you have a graph, you can tell, right, from that picture that I showed you before. However, if you have an equation, it might not be easy to tell. So if you look at, for a quadratic equation, ax squared plus bx plus c, the solution would be when that is equal to 0, right? And that's really given by that. So the roots are given by that. So what really gives us a lot more to say is this discriminant. Gives us a lot to say about the roots. So we're going to be looking at that. If this is greater than 0, if it's negative, what's happening? If it's greater or equal to 0, what's happening? If it's equal to 0, what's happening? In all those cases, that's basically what we're going to look at. So if our discriminant is less than 0, then the roots are imaginary. If that thing is less than 0, it means that it's negative, and we sort of like saw that gives imaginary roots. And we're not gonna really talk much about that, as it says, it's beyond the scope of what we're talking about. If delta, or the discriminant, is greater or equal to 0, the expression under the square root is non-negative, right? It means it's non-negative, and therefore the roots are real, right? So for real roots, we have the following further possibilities. So let's understand. We have that case where it's less than 0, we say it's imaginary. Then we have this case where it's greater or equal to 0. So we say it's non-negative, therefore we have real roots. That's really what we're going to be looking into too much. And we're saying if delta is equal to 0, right? The roots are equal, and we say that there is only one root. So we have, if the roots are equal, if delta is equal to 0, we say that the roots are equal, and we can say that there is only one root. Now, when we say there is only one root, we do not necessarily say there is one root. We're just saying that there is one repeated root. So it's the same root appearing twice, because in an actual fact, in a quadratic function, we cannot have only one root, right? If our delta is greater than 0, then it means that the roots are unequal, right? And therefore, there are two further possibilities, right? So we know that the roots are unequal, and there are two further possibilities. And the first one is that so the delta is, so basically the first possibility is that delta is the square of a rational number, right? And then in that case, the roots are rational. Or the other one is that delta is not the square of a rational number. Therefore, the roots are irrational and can be expressed in a decimal or a set form, right? So, for instance, what do we talk about here if delta is a square of a rational number? So, for instance, delta could be 4. If delta is 4, we're going to have rational numbers. We're going to have plus, minus 2. But if delta is square root 3, we're going to have plus, minus 1 point something. Do you understand? That's really the distinction there. Let's go through it again. We're saying that if delta is less than 0, then the roots are imaginary, right? They are non-real. But if delta is it's greater than 0 or equal to 0, then we're saying that we are in the real set, right? We are in the real set. Now let's look at if delta is 0, right? If delta is 0, the roots must be equal. The roots are equal, and we therefore say that there is only one root. But I've explained, in essence, there is one repeated root, right? And then if delta is greater than 0, right? It could be 1, 2, 3, 4. We then take all the perfect square numbers and say, if delta is a square of a rational number, right? The roots are rational, right? And if delta is not a square of a rational number, the roots are irrational and can be expressed as a decimal or in set form. Really, guys, that's really what we're talking about. If you put that in the diagram, that would be delta, right? If it's less than 0, you're looking at imaginary or non-imaginary. If delta is greater than 0, you have real roots, right? But in real roots, if delta is equal to 0, you can have equal roots, right? But if delta is greater than 0, you can have a squared rational, right, where you have rational roots, or you can have not a squared rational where you have irrational roots. So you can see that this is the case where delta would be less than 0, and you'll be looking at that. Or you can have that where roots are real and equal. You can have that, and then you can have a mix of these guys, right? So guys, I really hope, I don't want to jump into examples in this, but I really hope you try to understand what's happening. If you're struggling with what's happening, talk to me. I'll upload another video where I talk about it, perhaps using a different source, or but I will end there. The following video would be some examples. So let's look at that. Okay, bye guys.